Hello everyone. Welcome to today's Leetcode video. So, find the number of distinct colors amongst balls. You are given an integer limit and a 2D query of n cross of size n cross 2. There are limit plus one balls. Okay. Uh, so limit is 4. So there are 5 balls. Okay. And uh, labels from 0 to limit. Initially, all balls are uncolored. Okay. If for every query of form XY, you mark ball X with color Y. After each query, you need to find a number of distinct colors amongst the ball. Okay. Return the result array of length n. The result of I denotes the number of distinct colors. Okay. Note that when the answering a query, lack of color will not be considered as color. Okay. Got it. Let's take look at an example. So limit is 4, so 5 balls, and queries 1 comma 4. So in first round, 1 will be colored with 4. In second round, 2 will be colored with 5. Third round, uh, 1 will again be colored with 3. So it will be removed. 4 will be removed and 3 will be colored. Okay. And fourth round, 3 will be colored with 4. Okay. So it makes sense. Let's take look at this other example. So in first round, 0 will be colored with 1. 1 will color 1, 2. 2 will again be colored to 2. So that's why I think this is 2 because the distinct colors are 2 only. And 3 will be colored to 4. So 3 and 4 will cool. So I think we can do this with two maps. That's what I see right now. So how can we do this? Or can we do color and place? Can we do that? Can we make a map of color and place? Uh, unordered map. Let's let's try to solve it on paper first. So let's try to solve this one because this gives us a better understanding of how things would work. So okay, so 0 to 1. Okay, 0 will store 1 and 1 will store 0. Cool. With the first one. And we'll get the answer from here. Now, in the second map, 1 will store 2 and then will store cool. Now, in this third round, 2 will store 2. And as 2 is already there, we'll also have 2 store 1 and now 2. Okay, cool. If there was a replacement here also, let's add a replacement. Now, comma, uh, 0, comma 2. Let's add that replacement also. So after this, 3 will store 4, and as 4 is not here, 4 will store 3, 4 will store 5, and as 5 is not there, 5 will store 4. Now 0 is already here. So 0 already stores 1. So I'll remove this. So from 1, I'll remove 0. So, and when I remove this, if the um, value becomes empty, we delete this. And now 0 stores 2, and 2 will also store 0. So at the end, we'll have 3 with this. So 4 will convert to 3. So I think that is the way we are doing it. Let's unordered map in comma in empty uh, ball to color, and then have unordered map int comma vector int color to ball. Color to ball. Okay, cool. So we go for auto x mm, x of query. Okay, for every query, vector int res, cool, and we return res. Cool. For every query, what do we do? Firstly, we check if not ball to color of ball to color of x of 0. So if that ball is not colored, in that case, what do we do? If that ball is not colored, we color the ball. So the process of coloring the ball is ball to color of x of 0 is equals to x of 1, and color to ball of x of 1 is equals to x of 0. Cool. Dot push back, sorry. Uh, push back. Else, else if it is already colored. So let's go back a bit. Okay, if it is already colored, in that case, firstly we find what color it is. So color will be ball to color of. Then we delete that So let's make it a step, I guess. Like, um, this insert. Let's do insert. Uh, okay. So now int color is equals to ball to color of x of 0. Cool. We have the color. Now color to ball to ball, ball of color ball erase. What do I want to erase? X of 0? Yep. X of 0. If color to of color dot size is equals to 0. If the size becomes 0, we uh, do map dot erase color to ball dot erase color. If this is 0, if this becomes 0, then we okay. So and we also change this. So lastly, we change ball to color of x of 0 is equals to this. Let's. It seems like a good logic. Let's see. This dot push back dot size color the ball dot size dot size. Let's see if this works. Yep, it works. Let's try to submit it. Let's see. It's, yeah, it's a very bad complexity. Like complexity wise, it's good, but it's bad time. Let's do it a little bit better. Firstly, what I can do is I can remove this. I can remove all this logic. I can remove this because this is either way done. So yep, light betterment, I think. I hope. Yep, very slight. Uh, let's do something better that we can do here. What can we do? How much time did it take me to think of this? Took it like 14 minutes, which is good. Uh, is there a way I can make it better? Hmm. What is my time complexity? It's number of queries into a log of that point, log of n, log of n, and at max, yeah, and log of n. So number of queries log n log n. Okay, ball to color. Instead of this, I can take also int. Huh, ball to color of size limit plus one. So mm, that would let's make it a vector. Mm, mm, mm. What is the limit of limit? 10 raised to power 9. Okay. Um, and run. Why is this wrong? Slightly better, I think. Memory limit. Vector increases the memory. Ah, okay, I do get why vector increases the memory, but okay. Complexity wise, both are same, but I do understand why that happens. Is there a way to optimize this? Because we are very down. Just look at the editorial. Hash map and other. Yeah, they are doing very similar thing, but color map ball array. Oh, they are just storing the number, which is much better, I think. Yeah. Let's add that thing. It's just storing the number, which is obviously much better. Um, mm, nice, nice. Okay. Uh, let's do this video. What's this? 34%. That makes it a bit better. Two hash maps. That is what I did. Yep. Yep. So this is the best answer, I guess. Two hash map. Yeah, this is exactly what I did. Cool. I guess this is it for today's Leetcode problem. Total time around 22 minutes. Time complexity around with like proper discussion, I guess. Uh, Time complexity is insertion into a map is log n and oh, no, it's constant. No, for an ordered map, it's constant, and queries is this n queries. So the O of n, and let's analyze it.